In this episode, we're going to look at refactoring tests. Hi, I'm Mark Bradley, and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're going to look at refactoring tests. This video is inspired by a tweet from the publishers, the Pragmatic Programmers, asking for actionable advice people forget to give about unit testing. My response was around deleting tests that you used to get you to a certain point of the implementation. Let's look at the code. During this demonstration, we're going to make a start on implementing the Bowling Game Kata. We're not going to finish it, we're just going to get through some of the first few tests. And then if you'd like to pick it up and continue the kata and playing with the same kind of refactoring, deleting tests that got you to a certain position, then feel free. Let's make a start on our first test. So, for those of you that aren't familiar with the Bowling Game Kata, the kata is a challenge to create a function that takes a string representation of a single game of bowling and returns the score for that string. During the implementation, we can assume that the given string is a valid, complete game of bowling. So there's no need to do any validation of the incoming string. We're just going to look at it and work out what the score of that game was. We're going to start with the most straightforward case for a game of bowling, and that's what's known as the gutter ball game, where for all of the balls thrown down the alley, not one pin was hit. Hence the gutter ball, the idea that the ball always ends up in the gutter. So we will test gutter ball game. Okay. And we will do assert equals, do this assert, sorry. Assert equals, so we're expecting the score of 0, no pins knocked down, for game score, and we'll pass in the string representation. So in bowling, if you don't hit any pins with a ball, then you represent that with a dash. And for each frame, so that's for when you see 10 pins, you get 2 balls or 2 chances to knock down as many pins as you can. So we knock down no balls without, we knock down no pins with our first ball, and we knock down no pins with our second ball. And during a game of bowling, a player gets 10 frames. So we need to repeat this pattern 10 times. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I missed one. Sorry. 10. That's better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So that's our full game of gutter balls. No score for our first test. Okay. So what we can do, give us a bit more space there so we can see it. Okay. So our ID can tell us that this score function doesn't exist. So we can add the method over here. Score takes a string. Let's call this the game. And let's define it as a string. So, and this returns an int. So it must return an int, so make it valid, -1. So we have our test, we have our test should run, the code should compile, so we'll test that. Okay, let's run tests. Okay, so our test did run, the code was compilable, the code can compile, but we have a failure. We are expecting 0. Well, we ran test, but we're getting -1. So we can make a quick change to our code to fix that, and we can this. Okay, so hopefully this makes our test pass. Let's have a quick check. Yep, one test passing, so we're good to move on to our next game or our next test. So we'll create a new test, and let's say that we get ever so slightly better at bowling. We want to start understanding the logic now, and in our first frame with our first ball we hit one pin, and the rest is gutter ball, meaning that we should have a score of 1. So we'll go single test, single pin, first ball, first frame. Okay, so we'll just do a quick copy and paste job here. So we know we're going to expect 1, and the game should look like so. So the first ball of the first frame was hit 1 pin down. I think that's our test setup, so we'll run our tests, and it fails. So we're seeing what we expect to see at this point. We expected 1, but we got 0. So we can look at the quickest and most straightforward way to implement this. And what we do know at the moment is if the game looks exactly like this, we can return 1. So let's do that. So if $game equals this, put some brackets around it, return 1. Okay, let's run our test and see where that gives us. See if that passes, and it does. So we're now able to move to the next test. What we can do is let's just copy and paste this test this time. So we want to see if we can start working better on the logic. So single pin, first ball, first 2 frames. So we're going to do 1, miss, 1, and miss all the rest, giving us a score hopefully of 2. So let's run the tests. And again, we're failing. We're expecting 2, but we got 0. So we'll just do a quick fix. Okay, so if it looks like this, then we return 2. Okay, so that's looking good. That passes, so let's go on to a next test. So we're still, I don't think we exhausted this. I don't think this is going to be kind of anywhere near what our final implementation looks like. So let's see what we can do if we add another one, and we can say the first 3 frames. So add another one here, change expected to 3, save, let's run our tests. I think you know where we're going. We're failing, we're getting 0 where we expect to get 3. So at this point, there's an opportunity we could now do another copy and paste job and return 3, hard coded. That doesn't feel like we're getting very far, and we could just sit and do this all day for all the possible combinations of score. It would work, but it wouldn't be a great implementation. So let's start moving towards putting some better logic into our function for score. So how about we do something like this? So we know that a game is made up of frames, and in the case of our string, the frames are separated by a space. So we could get each of the frames. So we could do something like frames, spell it right third time, equals split. String split. Oh no, hang on, sorry, not split. I'm thinking explode. I want to use explode. Yep. So we want to explode on spaces. So we want each string where there's a space to be a new element of the array, and we want to explode the game. So now we have our frames. So what we could do now is we could go for each $frames as $frame. And then we can look at the first element of every frame. So we could do something like if $frame and we want the first bit, we want this bit, so we can get that by doing this, does not equal a dash. We can do $score equals 0, return $score, so brackets, and then we do $score plus plus, because that's currently our understanding of if it's not a dash, then we just increment by 1. Okay, then we return the score. So hopefully, if we get rid of this bit of code now, this should mean all of our existing tests pass. Our guttable game should return 0. Here we should get 1, 2, and 3. Let's run our tests and see if we've managed to. Yeah, we have. So our test pass. We are now in a really good position to move on. We've got a nice piece of code here. Now is a great opportunity to look at some refactoring of the code, the tests we've written. So we've got our guttable game, and we've got our first pin, first frame, first 2 frames, and first 3 frames. So these tests have got us to the point of this implementation. This first test gave us just a return 0. This gave us an if and return 1, else return 0. This gave us another if, checking for the 2, return 2. And then here, this third test got us to this slightly nicer implementation where we're actually putting a bit more logic in than just checking what the string looks like. So at this point, we can do a bit of refactoring, and we can take these first 2 tests that got us to this current place and delete them. They work quite nicely, but they're not needed anymore. They're duplicating our understanding. All we understand is if we have a 1 here, then we increment our score by 1. So we can delete these because this is all understood throughout all of the games. So we'll take these out before we start our next test. And now we're in a position to add some more understanding of the game of bowling. What we can do now is we can start looking at scoring more than 1 or knocking down more than 1 pin with a single ball. So let's take our function. So let's do this. So public we'll create a new test using test. So we'll do 2 pins, first ball, first frame. So you can see we're going back now to kind of where we were. So we'll take this line and we're going to say 2 because we're going to score 2 here. Save. Okay, so we'll run our tests, see what happens. So we expected 2, but we got 1 because from our previous test, our only understanding was as if you don't miss, you get a score of 1. Whereas now our understanding of the game is growing a little bit, and if you knock down 2 pins, you actually get a score of 2. So we need to make some changes to our logic. We could go else if frame 0 equals 2. brackets again. Sorry, I've been writing too much Go recently. So we can do score plus equals 2. So we're adding 2. Let's save that. Let's run our tests if that makes that pass. No, if frame 0 equals 2. Yeah. Score. Oh, hang on. No. So what we need is, I put it around the wrong way. So we can say this, x, put this above. Sorry, if, and then it's x, else if, like so. I think that should do it. Yes, so that passes. And now we can move on and do the same for 3. We can take this one, first ball, so 2 pins, so 3 pins. On the first game, so the score should be 3. Save. Run our tests. It doesn't match, okay, but we know what we can do. We can do copy this equals 3. So we'll save that. Let's run that. Okay, so that test passes. Okay, so now we're starting to build up our understanding of the game of bowling, which is a really good thing. And we're kind of stepping through now. We're understanding that depending on how many pins you knock down with that first ball, you get that number added to your score. But we're slowly incrementing our way through it, and the code's getting a bit messy again. So is there anything we can do that will force us to kind of fully understand this functionality of the game of bowling and make us write some implementation that would make this all pass and cover all of our understanding of this first part of scoring the game of bowling? So what if we took this approach? So create a new test, and we could do something like test simple scoring cases for first ball in frames. Okay. Let's take this example, and we're going to just change it up a bit. So we want this test to kind of explore all of the scoring of the first ball of the game. Now we need to understand dashes. The dashes are zeros, and we need to understand that 1 is 1 and 2 is 2, and so on. So what we can do here is we can cover all of the cases where it's either nothing or a number. So it is possible to go basically, so if you hit 0, if you hit no pins, you score 0. If you hit 1 pin, you get a score added of 1. 2 pins, you add 2 to your score. 3 pins, 3 to your score, and so on. Up to 9. And beyond 9, there's a new special case if you knock down all the pins with a single ball, which we're not going to cover yet. So we can cover all of these cases in a single test. We can just do 3, and 4, and 5, 6, 7, 8, and 9. If we add up all of those, it should equal, I think it's 45. Save that. And if we run the test, we expected 45, but we got 12 because our current logic doesn't quite get us there. So we need to make some changes to our code that will enable us to get that score calculated correctly. With our previous test, we got to this case where we were adding an if, where we were checking the number and adding that number to the score, which is okay, but would mean we'd have quite a large set of if-else's here. And we don't really want that. So how can we improve this? Can we get it down something a bit smaller, could we do something like this? For our current understanding, we know if it's not a dash, it's a numeric. It's going to be a number there because we're always given valid game string. So can we just rely on Go to convert between types and just say plus equals and the value of that ball, like so. If we want to make it really clear, just cast it to an int, like so. So that makes it nice and clear that we're taking what we assume is a numeric, casting it to an int, and incrementing the score by that number. So let's see if that solves our problem. And it does. Great. So now let's look at our opportunities to refactor some of these tests we've written. Let's look at our last test. It's covering a case where the ball goes in the gutter and we miss all of our pins. It's covering the plate where we hit 1 pin with the ball, 2 pins, 3 pins, and so on. So we now have a single test that describes or displays all of the simplest forms of scoring with the first ball in any frame. We've got missing, we've got 1, all the way through to 9. So these are the kind of simple cases. So this takes the opportunity to these tests we've got now, which are 4 tests before it. We can delete these tests because this one test shows the same logic, the same understanding of bowling scoring. So this 3 can go, the 2 can go, the 1 can go, and even the gutter ball can go. And there we are. So we're now down to a single test. We'll just check that passes. So we're now down to a single test that shows us a nice explanation of the game of bowling. All of the tests that got us to this point have been deleted because they're duplicating our understanding of how we score bowling, because they're just building us up. They got us to this place where we kind of have an understanding of how the simplest form of scoring of bowling happens, and we have a nice implementation of this. So, and that's where I want to stop implementing the Bowling Game Kata. I'm going to leave it here. If you want to take over and have a play with this, building up the understanding of scoring, you can go straight in and you can follow what I've done and do the same sort of thing with the second ball of each frame, starting with your gutter ball, moving into understanding one ball of one frame and moving through as we've done in the same way, and then deleting the tests as you start to duplicate that understanding. And then you've also got the opportunity to carry on into things like spares and strikes and seeing where you feel comfortable deleting tests because you're duplicating some understanding. It is possible that you could get to a final single test, but I think that's probably taking it to the extreme, and maybe I've taken what I've done here a little bit to the extreme by deleting so many tests. I could have left, if this was a real case, I probably may have left a couple more tests of the steps to get here so that people understand it. It's a decision kind of you need to make, but what I wanted to show was that you can delete tests. Deleting tests are fine when those tests are just duplicating your understanding of a scenario. I hope you found this video useful, and I hope you take the opportunity to continue to play with this Bowling Game Kata. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.